Today we're going to work on Department 56, the Scaredy Cat Ferris Wheel. I picked this up from somebody who needs it repaired, and they said that it's already been opened to try and fix. I have not opened the box to look inside of it yet, so we're going to be the first to do it together, I guess. Said it's not working, it's not spinning, not lighting up correctly, sound issues. Oh, and there's no adapter, so I'll either have to find one or make one. Not a big deal. Wow, that's stuck in there. Looks like a standard style adapter. Oh yeah, she's not together. That is a tight fit. It's getting wedged on the cars. There we go. Well, let's get this stuff out of the way. Okay. That's all out of the way. Now let's take a look at this, since it's already been partially dismantled by the owner. We got a little damage on the bottom. Just get the top off. Let's see what we can see. Well, that's kind of an interesting and probably a relatively good idea. The motor drives a pulley, which turns the wheel, as you can see, and the pulley actually runs the belt through this plastic housing. Keeps it out of the way, keeps it clean. Kind of a smart idea. Not something you see too often. Alright. A screwdriver. There's one screw holding the circuit board in. That way it'll give me just a little bit more room to move things with that circuit board out. Take the screw out of the way. And I'm going to go get a power supply in a moment. I'll probably go onto their website real quick and verify the voltage. I don't see anything on the board. Sometimes I'll print the voltage on the board. I'm also checking the components on the board to see if the capacitors are bulged, or if any of the resistors or diodes are burnt, or the transistors are burnt. Everything looks pretty good. On the back side we have the blob chip and just some soldered wires, which all the wires do appear to be hooked up. We got a little flat paper cone speaker, predates like with the piezo style, and I think we have a stepper motor here. We do, which is why I can't rotate the pulley to turn the wheel, but I can rotate the wheel where it slips the pulley. Stepper motors have a transmission built inside that steps up the torque. Sometimes it's the speed, but generally they use them for torque. And what you're trying to do is drive everything backwards, which is really tough on the gears, and then you tend to break them when you do that. So the belt slips, but it doesn't turn the pulley. It's just slipping over the pulley, but that's why the pulley doesn't turn the wheel. So, as far as the components go, they don't look bad. I don't see anything obvious. I don't see any discoloration on the bottom of the circuit board. If you overheat a resistor or a resistor shorts out, doesn't burn or burns open, they usually discolor. These are nice and blue, that one's gray, and then of course those are tan. There's a diode right here, which is a clear diode. Well, it's got a clear coating on it, and there's one right here. They look okay. Got a resistor there. This is a capacitor. These four, this little blue one, and this little brown one, and then this is a relay. It's a 12 volt AC relay. Interesting. So, not knowing anything about this, I'm going to assume this is an AC unit. Which means that I believe there would probably be some sort of rectification. I don't know. 12 volt AC and 24 volts DC. So I'm going to do a little research and find out what the power supply is, if it's AC or DC, because that's very important. You never want to hook up AC to DC and vice versa. You can burn stuff out very fast. Some cases there's a protection circuit, but the power comes in right here. Let's see. Here's the power. Power's right there. What they call J5. The power circuit runs all the way around the board. This junction here, which is the relay. So based on that, I'm going to assume it's AC, but I'm not sure. Double check. Potentiometer feels good. Doesn't feel sloppy or gritty. Most people know it as a volume knob or a speed knob. It's right there. But it's nice and smooth. Doesn't mean it's not broken, but it has a positive stop in both directions. It's not trying to overtake it. So I'm going to do some research real quick on what the Scaredy Cat takes as far as power, voltage, and if it's AC or DC. And then I'm going to get an adapter. If I don't have one, I'll have to make one. And we're going to give this thing power and find out exactly what's not working on it. Trace it through. I'm going to assume it's going to be a bad stepper motor. If the motor goes bad and it goes to a short, or the motor's binding where it's causing it to get hot and draw a little bit more power than it should, it can cause the functionality of the entire unit to fail. Because the more power is going into it than it's supposed to. Eventually, it would burn something out on the circuit board, usually the part of the board that drives the motor. The reason I say it's probably the motor is it's usually the most common thing to fail on animated items when you have an electrical problem. The motor connects here, and it connects here. So one side of the motor connects to the relay, the other side connects to a rectifier. This is AC in and DC out. The symbol even shows it. So, it's definitely an AC adapter then to run everything, and it uses a rectifier. So, I'm going to do some research. We'll be back. Hopefully, when I do my research and we be back, I'll be back with the correct adapter. Alright, I'm back. I do and don't have the right power supply. I have a 12 volt AC 850 milliamp AC adapter. Has the wrong end. And I'm not cutting this one off because this actually goes to one of my houses. It's not a Department 56, but it is the correct voltage, and it has a higher output amperage rating than the original. According to my research, this is a 650 milliamp AC adapter at 12 volts, and this is 850 milliamps AC adapter at 12 volts. So the voltage being higher is, or excuse me, the amperage being higher is fine. The voltage being higher would be bad. So I'm going to make one. since this uses a barrel type adapter or jack, I have a barrel jack, male, and I have a, most people refer to this as a headphone jack, which is a, I think it's a 3.5. So what I'm doing is just plug this in here. Maybe not, because it's the wrong size. So I guess I'll find another one. So that's the random junk channel. I got random junk. Let's see. Well, we'll use one of these and solder onto it. Right size. So. So I don't throw stuff away. Then you'll need it down the road for something. And that's how we got our name. What I'm doing is I need to find out which of these multiple pins is the one I'm going to be using. So instead of using the, put that on AC, I'm going to go plug this guy in like so. And I'll step it so y'all can see it too. 12.8 volts AC. If you can see it in the camera, the AC is right there. Now what I'll do is pop this bad boy in and find out which of the 1, 2, 3, 7 pins I need to solder to. Which two? Not that one. Not that one. Nope. Nope. Let's try and get a better view here. Let's tip that up a hair since I'm now sitting. Alright, there's my 12 volts. So it's the back pin and this inner pin. Soldering iron's nice and hot. And the cable's caught. There we go. There we go. Yes, I know there's still 12 volts power on here. As long as I don't short the pins together, it won't hurt the power supply. There we go. So I'm going to solder these. Now, if this was DC, polarity would make a difference, but this is AC, which means alternating current, which means polarity doesn't make a difference. In some cases it can. That's why we have polarized plugs. That's why one side's fat. We always trim them off at Christmas time with a pair of side cutters, so we can plug our Christmas lights in. Nope. That was a little warm. Let's try that again without touching the skin. Sparky. Maybe I should unplug it. Since it's getting a little toasty on my fingers and I sparked it. So, don't try this at home because apparently I'm trying to do it the fast way. So this video is not 6 hours long. And I'm not helping it. I'm sorry if it's out of frame. I can't look up to see while I'm doing this since I already slipped and burned myself once. The Random Junk Channel, we make random mistakes. Tastes like chicken. Put the hot stick away. Make sure that my wires are not touching anything, that my solder didn't jump since they're really close together. It looks okay. Now we're going to test the voltage to make sure that when I did spark it, I didn't damage the power supply. Usually they're pretty resilient, but wouldn't surprise me. Yep. Now we'll do this. And then I should have, there we go. Quick, relatively easy adapter. Minor skin burn, we're fine. All good. Hey, lights up. Wow, that volume is... There we go. I was going to say the volume sounds horrible, but then I remembered, oh, there's the volume up. So, we have lights. And we have lights on both sides. Yes, we do. Power off. Does it do the volume without the... Nope. So, I'm going to assume it's the motion. Power on. Volume. Wow. That motor is definitely got a problem. Woo! Alright, so it definitely has a motor issue. I don't know if you can hear it, probably not. It's probably not loud enough, but it is humming badly and the whole thing is vibrating, which means the motor is probably locked up. But hey, the lights work. So, next part is stepper motor. Let's take it out. I always say, remove power. And keep it from touching anything metal. We just unplug it. There we go. Remove my adapter. And let's see what it's going to take to get this stepper motor out. Jeez. And also with this plastic piece broken, it's not going to help any because that's the anchor for the motor. Probably going to have to resin that in because that's not good to have the motor housing free floating like this. So what is holding you in? The top screws are out. To get the top screws in your screwdriver, and you're going to have to feed your way through the Ferris wheel like so. But they're already out. You can see the housing moving. But I can't see what's holding the bottom in. There's something on the bottom that's not obvious. So I'm going to pull out the speaker. Alright, it's caught on the pulley. Sees my problem. Alright. The problem is there's a screw dead center of this pulley, which I'm going to see if I can get to. And that's my problem. Now, like I said, this person started taking it apart themselves, and I totally encourage that, because the only way you're going to learn to do stuff is to try it. It's not always successful. I've had my failures and my successes. So there's the screw I just got out. Now, let's see if I can get this assembly out. I'm going to need something to pry the pulley off. So I'm going to use my pulley prying tool. There we go. Alright, so here's the stepper motor. There she be. And the pulley, if you notice, this has got a 2 flat spots on this round shaft, so it's kind of a weird oval. Fits into the center of the pulley, and that's what turns it, and then the flathead screw just keeps the pulley from walking off. This motor has definitely got an issue. This motor, I'm going to say, is DC. And the reason I say that is this rectifier is on one side of the motor and the relay is on the other, and the relay is a 12 volt AC and a 24 volt DC relay. So I'm sure there's DC going to the motor, probably close to 12 volts. Most stepper motors are around 12 volts. They do make smaller ones, usually this size they're 12. Smaller ones can be 9 or 6. I even own one that goes down as low as 3 volts. Yep, 12 volt, 5.6 RPM, 60 hertz, 3 watt. Oh, it's an AC motor. Interesting. There's your motor. And let's find out which part of it is bad. Now, stepper motors, there's little indentations right here. There's 1, 2, 3, 4, 5, 6 indentations. This top plate is put in and then they just pinch these little fingers over to hold this plate on. There's no screws, it's just a little plate. Now, you're supposed to pry up them little fingers to get in here, and each one of these pins is a gear cluster. Usually 1 or 2 gears, or 1 gear with 2 steps on it. And it just goes around. The motor's usually in the middle right here where this is, and then it goes this way to here. And then it turns that as the final part. This screwdriver, unfortunately, I broke the end of it off, doing exactly what I'm going to be doing now, which is trying to pry these tabs up. Normally, if you can get about half of them up, you can pop the plate out at an angle. And then take a pair of pliers and push the other ones up. Because this is really tough on a screwdriver. A hardened screwdriver, it's really easy to break the tip off. I get enough of it up. Pry my plate off. Nope. Oh, let's see. I'm hoping I got them up far enough that the pliers will grab and I can flatten them out. Come on. I need a smaller blade screwdriver so I can break the tip off inside of it. You know. Definitely do not want you in this thing. Oh, that's pretty common for most things anymore, truthfully. Come on. I think the reason I'm having a problem is this finger is not up far enough. Now let's see. definitely are not making this easy. There we go. Got it. So, now I got the one side up. In most cases, once you lift it high enough, you can pull it over out of the other fingers and then lift this top plate off. Like that. Holy smokes. Let's put the grease in. There is your stepper motor gear cluster. We'll put that back in since it flew out. So, yep, I was right. Center, worked its way around using two-step gears. The main drive gear is one, and then these are all different gear reductions to get to your output shaft, which is the pulley, and then it rotates the big wheel. It's supposed to rotate the big wheel. So now what we're going to do is find my adapter, plug it back in, and plug this one back in. So I want to see if I can make the motor turn with no load, which I can. I don't know if you can tell, but that motor is spinning right along. And if you notice, the lights aren't straining now. So, let's find out what's going on. Generally, when you pull this apart and the stepper motor starts spinning, in most cases I've seen, one of the gears is broken and is causing it to wedge. Now, I'm not saying that's every time. I have had a stepper motor where the motor's actually burned out. It does happen. But a cracked gear will wedge the motor. So, there we go. So now it's time to inspect these little guys and see if we can find a split. Or it's the stepper motor gear itself. That's usually the most common one. But make sure we get all the teeth. One thing I do know about Department 56 is they use a lot of grease compared to like Lemax. Lemax puts gloves on, but I noticed Department 56 like fills the entire housing up. And then you got greasy frickin' fingers, which, you know, it's fine. There's two rules of thought on grease. One is too much it ruins your item because it attracts dirt and causes the grease to get chunky. The other is too little, it burns up. And then this is the motor, technically, the armature with a magnet inside here as the AC or DC, whatever this sends out. I believe it's DC pulses. It spins really fast. The reason I pulled this out is I want to check the gear. First thing I gotta do is wipe off the inordinate amount of grease. Which is still on my nail polish. I would normally turn on my overhead light, but that decided it didn't want to work as of this morning. Burned out, I dismantled it, thinking it was a bad power plug. No, it's just burned out. do not see anything. I'm using a magnifying glass, and I'm putting pressure on the armature or shaft, the hole for it, with the angle or the taper of the needle nose, so if a crack was there, it would spread it. So maybe the problem isn't here, or maybe the plate was damaged, and maybe the problem's in this hub. It's a lot easier to do without magnifying glasses, I'll tell you that. Take some of this extra grease right here. It's all globbed on. And I'll wipe it on the center. So. And get in there. One last check of this guy. This is the hardest one to break because it's the biggest. And all the teeth on these things look good. All the hubs don't appear to be fractured. Seems pretty good. So, oh yeah, let's get these tabs bent up so I can actually put this back together the correct way and not fight it. Well, not fight it as much. The problem with stepper motors is they're sometimes hard to find the specific one you need. Most of the ones I have are DC. Possibly all of them are. So if this had to be replaced, I'd have to do some searching to find it. I know sometimes the Lemax and Department 56, they use motors that you just can't find anywhere, which is kind of annoying. Sides in. There we go. Flush, flush. There's two fingers on the outer edge. They're just alignment tabs, but they're flush with the silver part is flush with the brass colored casing. Fold over some of these fingers. That. Oops. Yeah, she doesn't want to turn again. Turn for a second. I didn't fold the fingers all the way down, which is why I'm able to pry it back up. I just want to put tension on it to test it. So, sticky grease. motor works really good. I'm putting a lot of pressure on it till it jumped a gear up. So I wonder if this is the problem. Is this wedging? Is it bent? Is the cup bad? Not enough grease in there. Get some of this extra grease. I am pushing down really hard and it is overdriving my finger. You can see the indentation. It's not like I was just lightly touching it. So, is this plate. It has an insert here. On big motors, that would be a carbon insert. I'm not sure what they're using here. Probably a carbon insert, because it does have some, it's darkening the grease around it. Is the insert cracked? It's wedging it. Now again, it's the big motors that have the carbon. They're a carbon ceramic. I don't know what this is. It looks like it's a carbon insert. It could be wrong. It's the same color. Could be zinc. Could be just regular metal. Generally it's a different type of metal. It might even be graphite. But that would be stupid, because if it wedged, it would shatter. So let's start putting the plate on while it's running. And see at what point does this motor bind. Before I do that, also, if you don't notice, I was pushing the grease into the center of the insert, was to help lubricate the steel shaft. If you notice, as it's spinning slowly, there's this brown stain here. There was one here as well, and it's full of, and the edge of this is black, which is why I'm thinking it's a carbon insert. I'm thinking that it's wearing down because this pulley's pulling up while the motor is pulling down to keep tension on it. And I believe it's kind of ovaling this insert, and it's filling up with fine dust particles, which can, over time, wedge a motor. It's pretty rare. It does happen. Moving parts don't particularly care to have grit in it, and that's what it's doing. It's introducing grit. That's why I don't think they would use graphite, because graphite would break down easy, but at the same time, graphite is a lubricant. You can get graphite lubricants at your hardware store. It's usually used for locks because it doesn't freeze. So especially if you're in a place that gets cold every year. So alright, let's see if I get all the little motor pins to line up in their respective little holes. Kill the motor for a second, just so I don't wedge it. Okay, it is turning. I don't know if you can see it. I hope you can. This is a new camera that's higher def than my old one, so hopefully you can see it spinning. Hopefully. She's still spinning. Maybe that was the entire problem, but we don't have a load on it. We're just freewheeling this bad boy. with nothing more than the tension of the casing. Still turning under my finger, not pressing down real hard again. Here's the indentation. So, I'm thinking the sleeve, whatever material they used, is wearing down from the tension of this, causing it to create fine particles of metal or graphite or carbon, wedging the output shaft. And that's what I was wiping off with the needle nose pliers. There's some discoloration on the tissue that I'll be using for the grease. So I am thinking that was the biggest issue, but we're not load testing it with the Ferris wheel. What I'm doing right this moment is I'm using the motor to spin and scrape off the black grease from the end of the shaft. And you might be able to see it. It's also sparkly. I mean, there's metal flake in it. Metal flake's not good to have in your grease. It's great to have in your paint job, but not in the grease of a motor. Alright, so let's put the fingers back down and see if the motor stops spinning. It's really tough on your screwdriver. So I'm going to use the edge of these pliers so I don't damage my screwdriver. Now, in all the years I've been working on Lemax and Department 56, which has been estimated, which was like 15, 16 years ago. I think the first 4 or 5 years are just lit houses, because I've been collecting since 2000. I've only ever come across one of these that was actually defective, meaning the motor was bad. Normally, it's always a gear. Always a gear. Well, either a gear is broke, a gear is bound, a gear is wedged. So, I do know people, not like personally, I do know of people, let's rephrase my wording, on the forums that have had these motors go bad. And again, to me it's pretty rare, because I've never really had a motor go bad. I've just had them break a gear. And trust me, finding a gear is sometimes just as hard as finding the frickin' motor. She's still spinning along, just humming in my fingers. And it is a little bit of a torquey motor, I can tell you that, because every time I turn it off and on, I can see the motor twitch. And they're using all 4 screws, which is pretty rare. Most of these guys just got 2 screws. They don't ever use all 4 slots. Some motors, the 4 screws are also 90 degrees out from each other. They're not 180 in a dual set like this. So they're expecting some load. They're using all 4 screws. Alright. We're all plugged up. The other issue that might be causing it to bind is the plastic is broken. And we're going to have to fix that. Turn it off. Whoops, let's turn it back on. I want to try and line up the direction of this to that pulley. Just makes it easier to put in. And let's also get these screws out of my way. These screws are causing me a little bit of a problem. They don't want to stay out because they're pushing up against the belt, which is kind of an issue. The other issue is the pulley is not aligned. So I'm fighting with the nose of the pulley, the two screws, and the broken base. That's the trifecta of pain in the ass. Alright. I can get one screw and the broken base. Oh, two screws and the broken base. And I just lost a screw. Son of a biscuit. There we go. And now we need to get the pulley on. There's the other screw. Alright, now I don't have to worry about fighting the screws anymore. Now, guys do this at home, I'm not going to envy your struggle. I got the pulley on, but popped the two screws out. Wow, that's kind of a pain in the ass. I'm not going to sugarcoat that one. Small fingers and a magnetic screwdriver are probably going to be your friends if you do this at home. Is either one of these lined up good enough that I can do this? Of course not. Had to fall out. Take two. It'd fall out. You know what? Before I put the screws in, I will just hold this with my fingers, keep tension on it. Let's make sure it actually turns. Yay! So, the Problem with this? Bound motor. The little part that the little transmission, the gear reduction transmission was bad. Not bad, sorry. Dirty. So, a lot cheaper than trying to find one. Now, just need to get it back together again. I'm going to have to say one thing. Thank God they're freaking magnetic screws. Because this would be a royal pain in the ass if they were stainless. Come on. Find your way home, little screw. So since there's a belt in here, it's making life a little more difficult. There we go, I think. Little engine that could. Could it be? Yep. Not in there. I'm caught on the belt. Alright, I got it started. Now I just need to get the belt out of my way so I don't damage the belt. Holy smokes, I want to know who puts these things together. Because there's like no way to get in here. There is that one. Hope I didn't screw the belt. Yep. I got the belt cut under the edge of the screw. That's what I thought. Still caught. Let's not get blinded by the light. All right. I think I'm going to spend the rest of the night just trying to put these stupid screws in. Come on. So, what I'm going to do is, instead of you watching me for another half an hour to 3 days trying to get this stupid screw in, screws, 3, I'm going to stop the video. I'm going to try and get the screws in, and I'm also going to try and repair the cracked base and glue all this parts back in. The speaker, and the speaker looks like it's a hot glue, but the base is going to have to be using a really strong adhesion glue, like the Gorilla Glue liquid, which is this bottle. It's not super glue. It's actually glue. And then screw the circuit board back in, a single screw, which is over there, and put the Trickster ticket booth back on, which is not super glue. It feels like a hot glue. It's soft, spongy, stretchy. So I'll probably hot glue that back on. Yeah, because if it was super glue, it would just break off like breaking hard, brittle plastic or glass. So I'm going to spend God knows how long trying to put the screws in without pinching the drive belt, like apparently I did. And then glue it together, and we'll do one final check when it's fully assembled. I'm sure there's a trick, but I know if I call the Department 56, they'll tell me the pack sand. They'll do it politely. They'll say it's proprietary, you're not supposed to fix it, just replace it. The same stuff you get from most companies anymore. But yeah. So that's it for now. I'll be back when I get it done, and I'll explain how I got it done, whether it's just perseverance or if I found a trick. Because I think these channels are sealed. Yeah, the channel's sealed, meaning that just above where the screw hole is, there's a black piece of plastic that protects the belt the entire rest of the way. I don't want to try and pull the belt out. I might have to use another screwdriver or something to pry it off to the side more. I don't know. I'm going to play with it and see what I can find. I'll be back. Alright, we're back. It is back together. Had to let it sit for a day when I put the glue on the bottom to fix the crack. But she works. Everything's screwed together. Power. Oh, probably helps if I actually plug in the power supply. So, power. Lights up. Flashes like it's supposed to because it's not moving. Sound. A temperature. Let's do volume control. And then, motion. So when it's in motion or spinning mode, the lights are just on. When it's not, the lights flash. Similar to a real Ferris wheel of the old days. But, all back together. I did glue that base in with that liquid Gorilla Glue, which very important. That base is the stability for the tension on that belt. So, there's that. There's that. Now the lights will flash. Now it's just a static prop. Power off. So, that belt was a pain to put back on. I'm not going to lie. It was not easy. I required a pick. I used a 90-degree magnetic screwdriver to get most of the way in. Needle nose to hold the screw from the side, and then a smaller screwdriver if necessary, which only needed on one of the two because of the angle getting through the spokes of the wheel. Since it's not really easy to show, because the way the thing is set, how it works, I use a pad. So, looking at it from inside the wheel, through the spokes, you have a belt that goes up. My drawing sucks, so I'm sorry. And then you have a cover with That's open, and then the rest of the cover is up here, and then that would be your axle, the top part right here. The screw holes are right here. So using the pick from this side of the spokes, the side with the motor, I would push the cable, get underneath it, and twist the cable. So instead of looking at the edge of the cable, or excuse me, the belt, not the cable, the belt would go sideways and then twist. So, and it would get fat and then twist back to thin. By allowing the belt to rotate, again, my drawings suck, I was able to, once I rotated it, push the belt so the belt was curved like that, and the screw hole was accessible. The magnetic screw driver I could then fit through. It took dozens of attempts because I kept falling off because I'd hit the spokes of the wheel, and I could get the screw started, but I couldn't finish it due to the angle. And that's where the small screwdriver came in, and I could tighten them down. So it's not easy. I'm not going to lie, it was a kind of a pain. The first screw took probably 30 minutes of just fighting with it and then picking it out of the mechanism because it kept falling. The second screw took 15. You can try and pull the belt and then twist it, but the only way I could get it is if I pulled the belt, even though the thinner side you would think would make it easier, the problem is when I tighten the screw, I would actually pinch the belt. But by twisting the belt, so the belt would go from the edge and then twist flat, I could actually get more movement and I could pull it farther out of the way, and then the entire hole, because the belt would be over here now, would be open for a straight shot. Straight is subjective because with the spokes you can't go straight in. Your screwdriver is going to be at an angle, and a magnetic screwdriver is going to be a lifesaver. Unfortunately, most of these little electronic ones aren't magnetic. So it was kind of a pain. And the same thing with the pulley screw on the bottom that locks in the pulley so it can't walk off of the armature. Same problem. It is at the same height as the fence, so you have to come in at an angle. I could not get the magnetic screwdriver in there at all because of its diameter, and its that screw isn't as magnetic. It's a different type of metal. So I had to use this in tweezers. I also had it tipped up at an angle. I was actually balancing it on, that's why it wasn't plugged in, because I forgot. I had it tipped up, and I had it balancing on the power supply, like so. So gravity would help keep the screw from falling down and then fishing it out. Because I must have done that 20, 30 times. So, again, drawing's not the best. It is a pain. The difference between Department 56 and Lemax is Department 56 usually lasts longer. Like the belt that's in here is a, I don't know, composite belt or a layered belt. The belt, from what I can see, is looking through the edge. The inner row that goes around the pulley is brown. Then there is a black layer attached to it, and then a gray or green layer attached. So it's like 3 belts sandwiched together, probably with heat or resin or both, to make the belt ultra strong. Whereas Lemax, all their stuff uses standard thin rubber drive belts. The belt that's on here is measurably thick. It's probably close to a 1/16 of an inch. This is smaller than the pencil lead Lemax drive belt. So, Department 56 generally lasts longer, but when they break, they are much harder to repair. I've repaired several, and they're a lot harder because of things like this. They use a very sturdy, rigid belt, and they block the screw holes that hold in the mechanism. I'm sure when they built it, they probably have some special machine or tool or somebody with years of experience building this stuff, and they have a trick. The only thing I could do was use tweezers, 2 different screwdrivers, and a pick. I tried a straight pick, I tried a dogleg pick, and the only pick that worked the best was the 90 because I could stick it in And then once I pushed the belt out of the way, I could turn the pick to where it would grab either the wheel mechanism or the these uprights right here to hold the pick steady, where I could just balance it with my finger, like my pinky, and then sit there with the tweezers in one hand and then fit it in. But all in all, it took about an hour to put in the 3 screws, which would have bored the hell out of you if you're watching me do it. And plus, you might have heard some choice words. So we'll save you that. It does work now. It is back together. The only thing I have to do is hot glue this housing back on. I have not hot glued it on. So I just placed it on to make sure the alignment worked and that it did not bind the pulley or put any pressure on this upright that houses the belt and the drive pulley up here, which, as you saw, it does not. Now I will use hot glue and then push this back in all the way and scrape out what's in here. There's some right here, there's nothing here, and there's some residue on the bottom. So I'll pull this back off and then, of course, clean it and glue it so that way it's all back together. So, yeah, if you have to do this at home, don't fret. It is a pain. I'm not going to lie. It was not the easiest. It is a very nice piece. I actually like it. Something maybe I should have bought a long time ago when it was available, but it doesn't fit my motif, which is probably why I never did. But I kind of like the fact that everything, all the chairs move like they're supposed to. You know, they recenter themselves as it rotates. I like the lighting. And the controller is kind of interesting. 3 buttons. So, and what's nice about it is they use screws on the controller, so you can take it apart and clean the contacts or replace the buttons as necessary, because they're just standard itty-bitty electronic buttons underneath inside that are just momentary. And Limax ones you have to pry apart. Sometimes the stakes break and they're tacked with glue and you have to re-glue them. At least something like this you can rebuild by just removing the screws. You might lose these caps if you're not careful because they just free float. But all in all, it's fixed. Didn't require any parts. Just had to fix the base that was cracked. Again, I use this stuff, but you have to let it sit for 24 hours, which is why it took 2 days to do this. And it's under enough tension that the pulley is not slipping, it's not binding the motor or causing the motor to twist now that it's re-adhered. Circuit board's back in. Be careful with the wires for the lights, because when I was maneuvering it, trying to get the screws in, I broke the wire off. I had to re-solder it back on because the light wires were those 2 little black and white wires that were coming out over here on the bottom. They're very thin. Luckily, when they broke, I could look at the video, see where they were connected. 1, 2, with a set of magnifying glasses, the type that they use for electronics or jewelers. I was able to see the broken wires on the solder joints and resolder the wire back on. So be careful, because those are really thin wires compared to the wires for the power, the switch, and the motor. So that would be my only tip for y'all out there if you want to attempt to fix your own Scaredy Cat. The hardest part of the whole process is, I would say there's 2 hard parts. Getting to the screws if you have to take the motor off, especially these 2 outer ones on the uprights. And then the second hardest part would be removing this housing without breaking the plastic base. Because it appears to be a hot glue, I would use a heat gun or a hair dryer and slowly work around it to soften it and then carefully peel it away. Try not to melt the base, try not to melt the uprights, and definitely try not to burn that belt. I don't know how or where you would get that belt because it's a very unique belt. So, other than that, I hope you enjoyed. If you have a Scaredy Cat with an issue, hopefully this helped. I wish I could have shown you how to take the housing off, but like I said, somebody else tried to fix it, which is fine. I encourage that. And she wasn't able to. So I'm glad I was able to get it working for her so she can put it back on her display. So, thanks for watching the Random Junk Channel, and until the next one, have a good one.